going to be, you ready? Good. Once again, my name is Jason Verbelli, and our next speaker is going to be discussing a topic that everybody should listen to because it affects all of our lives, moving from nuclear technologies to these breakthrough energy technologies. So the 2013 Global Breakthrough Energy Movement brings you Mr. James Schmidt.
Thank you, and thank all of you out there, wherever you are. My name is James Schmidt, and I'm a retired aerospace engineer who had the opportunity to be in the military, and I became a nuclear weapons effects expert. Not hireable these days. And in that profession, I worked for the Air Force for about 7 years, and then I went into the the business side of it. So I worked with Northrop Grumman and TRW back in those days, and as an engineer and as a manager, mostly in a technical sense, project manager, and later on was into line management with that company. And our whole purpose was to maintain the ballistic missile systems that are stationed up in the northern states here. And so I'm very familiar with how nuclear weapons work, and when you're involved in understanding how nuclear weapons work and the effects of nuclear weapons, there's a whole slew of physics that is associated with nuclear weapons. And so I have a whole range of science and physics and chemistry that I've become acquainted with, and that was just fine with me because I like to learn about everything and be able to understand everything. And this is what, from the beginning, in early age, I had an interest in Tesla and fringe science, and so this science also enabled me to understand free energy and how the different types of free energy technologies work. And I've done my own experimentation, including doing some transmutation work with electrolysis. So I'm on both sides of the aisle here in terms of science. What I'm going to do today is I'm going to talk about nuclear power and the evils of the nuclear power and how we need to change that and get in transition into breakthrough energies very soon. And I'm going to talk about the methodologies for neutralizing nuclear fallout. I'm going to talk about alternatives to nuclear power. And what is the transition that we need? We can't just overnight transition. Can't just overnight cut the grid out there. We need to have some transition. And that's going to be basically the renewable energies that you're looking at right now. And then I'll talk a little bit about what's going to be the impact of breakthrough energies on people's individual lives. It's going to have a huge impact, and that's why we need to be going in that direction also. And then what is kind of a process? I like processes. I'm an organizer, a visionary, and planning kind of guy. And so, what is the process by which we are going to get there? I have worked with a group called New Energy Systems Trust. We're an incubator where we're trying to network inventors, free energy and inventors with professionals and manufacturers and those who might have the vision to invest in free energy. Nuclear power, what is it? How is it produced? It's basically taking uranium atom and splitting it in two, and in the process you create some extra neutrons which fission other uranium atoms and create heat in the process. And that heat is used to boil water, and that steam is then used to drive the turbine, and then you create your electricity. Unfortunately, there's some nasty stuff going inside the reactor here, and it's basically a controlled bomb. That's all this is, a controlled bomb. the way you control it is you put carbon rods down into in the middle of all these uranium rods, and you capture some of the neutrons and control the fission process. And when that gets out of control, then you have real trouble. That's when you have your meltdowns. There's a lot of radiation associated with this, and we're going to get into that. We're going to get into what do you do with the waste that comes out of here? What do you do if you have a catastrophe? And we'll talk about Fukushima too. Here's a Fukushima power plant. This was before BF, before Fukushima. Here's a chart of how nuclear power is kind of split out around the world, how it's used. There is a whole list. I don't have the whole list of countries here, but I just wanted to pick up the ones that are significant. There's 4 countries that have more than 1 billion kilowatt hours per year. United States uses the most nuclear power, but it supplies only 20% of our electrical energy. Russia only 17%, but has 165. France is overboard there with 75% of their energy come from nuclear power, with 404 billion kilowatt hours. Surprisingly, the Republic of Korea, South Korea, uses 30% from nuclear power and 143 billion kilowatt hours from that source. Here's a map of the U.S. nuclear power plants, just to give you an idea how they're distributed, mostly on the East Coast. Location of these power plants is critical from the standpoint of you want it in a place where it's not going to, if something happens catastrophically, you want it in a place where it's not going to affect too much. So you wouldn't expect you expect more of these plants to be out in the West. The problem is you need a lot of cooling water to cool these things. Millions of gallons a day has to be cycled through there. And so you have to have a place where you can have a lot of cooling water. That's why you have them along the seaboards. The fission products that you produce in a nuclear reactor come from the fact that you're splitting a uranium atom and you produce a kind of a double hump of atomic numbers. Fission products come out of this. And it turns out there's hundreds of products that come out, isotopes they call them, which are just different numbers of neutrons with protons in those different atoms. And they have what they call half-lives. That is, they're unstable isotopes, and they will decay with time and into a stabilized isotope. And some of them have very long lifetimes, some very short. In this case, because there's hundreds of them, some of them start to have a millisecond lifetime, and so they stabilize very quickly into something that's stable. Here's just to give you an idea of there's a big long list, and on the left-hand side here is the yields that come out of there, and on the right side is the half-life. And in this case, I just started with the iodine, which is at 8 days, has a lifetime of 8 days, so it's fairly short-lived, but just after an event and you're close to it, iodine becomes an important issue. And you have something like down here, another iodine 129, palladium 6.5 million years, and iodine 129 is 15.7 million years. In between here you have cesium, which is 30.17 years. That's important because it gets into your food chain, so it's around a long time. This chart looks same chart, but on the left-hand side we view them in order of yield, and so the bottom is the most yield and the least yield up on top. And I've highlighted in yellow here those isotopes that are important in terms of our health and the effects on life, and so that's why I've highlighted those in yellow. Get into our food sources and the air and so forth. The primary ones are iodine, cesium, and strontium. And early on in the air, you'll get xenon, but xenon stays in the air. The others will deposit themselves in the ground or the water. And so that's why we're concerned about those. When we talk about radioactivity, what are we talking about? Well, we're talking about particles that are given off from these atoms that can penetrate us and cause health problems. Well, there's three types of particles. There's the alpha particle. That is basically a helium atom. The center of the helium atom. And because it's so heavy, it's easy to shield out. And you can use a piece of paper and use clothing will shield that out. You just don't want to breathe it in, that's all. The beta is just basically an electron. It can go through paper, through your clothes. You need some kind of light metal to stop it, like aluminum. And then you have the gamma rays, which penetrate just about anything. Lead's about the only thing that will shield the gamma rays, and that's what a lot of the detectors measure as gamma rays. One of the issues with radiation is how do you measure it? I mean, how do you know you got too much? And so you need to measure it. And one of the things that the system has done, the scientists and the government, they've come up with these units that nobody can understand. Anybody know what a becquerel is? A sievert? These familiar terms to you guys? That's what they have done to us. Very difficult. So I'm going to try and go through that. Think of read. So you have the source. Radioactivity is the amount released at the source. Exposure is the amount of radiation that you expose to. So in fallout, they call it exposure per meter, per area, and then the absorbed dose. How much are you absorbing? And mostly we don't worry about the outside, but what you breathe in or eat. And then there's the dose equivalent. That is, once you absorb it, what is the radiation equivalent normalized effects? And we call that dose equivalent, the REM, radiation equivalent in man. That's what the REM stands for. So you start to understand it a little bit. RADS is typically what we talk about in measuring counts per minute. So you can understand counts per minute. A Geiger counter puts out counts per minute. And I'll give you an equivalency there. Here's some numbers down here. A Curie representing something at the source is 37 times 10 to the 9 becquerels, but you don't care about those large numbers. You need to understand how much is going to affect you. So that's what I'm going to try to explain here a little bit. Here's some radiation threshold levels. Average human receives an exposure of about 600 millirads per year. So that's just normal ground radiation from the atmosphere and so forth. One in 1,000 cancer risk starts at about 1,200 millirads absorbed, and the onset of radiation sickness is about 75 rads. And what I learned as a young guy learning about radiation effects is about 100 rads is absorbed radiation is about where you start to see people getting sick. The onset of radiation poisoning, where you start to have to take them to the hospital, 300 rads. And a key one that the media likes to use, 50% death rate in the population from cancer and various poisoning occurs at 400 rads. But all this is somewhat complex because it's dependent, not only dependent on the total dose that you've got, but how much you get, the rate at which you get it, and over how much time you get it. So there's different effects if you get 100 rads over 30 days and you get 100 rads over a year. But in all cases, they're cumulative. But we have an immune system that is really pretty fantastic. And it can deal with this, the radiation effects in the cells, and take away the antioxidants and the disease cells from the radiation if you're healthy and eating correctly, and there's certain things you can take. to deal with this. So it's a complex kind of issue. But you get overwhelmed with it, your immune system cannot deal with it. Radiation, high radiation dose rates will kill cells. Low radiation rates can alter the DNA, and so in young children and in unborn children, you can get these defects. Cellular damage, as I mentioned, depends on dose rate, accumulation dose, and duration of exposure. A dose of 100 rems in a few days would show some kind of symptoms. I'm going to talk about Fukushima, but I'm going to talk about it in terms of the United States. What has been the effect here in the United States? That's what we're interested in. And there's a lot of people reporting on what's going on in Japan. A lady, Helen Caldecott, down in Australia, has done a great job in trying to educate the Japanese to what's going on in their own country up there. We have no reporting from the NRC, the EPA, the FDA on what the fallout is here, what effects have already occurred here, and I'll get into that just in a little bit. We do have some civilian radiation monitoring system that monitors radiation in this country, and people can go online and report what they have got on their recorders. And so here's a map, and that is radiationnetwork.com you can go to. And you can join up and report your own readings on that. These will turn red if they get over 100 counts per minute. So, and 100 counts per minute is about 2 milligrams of radiation per day. So then you can determine, well, how much have I accumulated over 5 days, a week, and so on and so forth. So that kind of is the key number for you, just get you in a ballpark of how much radiation that you might have received. Some other interesting facts about the fallout from Fukushima. Around the planet itself, a lady named Janet Sherman, Dr. Janet Sherman, did some studies, and she estimates there will be about a 50% of the next generation in Japan will receive cancer, and that may go up from what's going on over there now. Radioactivity is now is increasing. It's entering the groundwater. There's a big plume coming out from Japan and heading toward our west coast. Some say it's already here. And so now you're worried about the fish that you're going to be eating out of the ocean and absorbing the radiation from the fallout in that. The radioactive cooling water, they're having to put more cooling water in through the damaged facilities there, and that is flowing out into the ocean. So that will continue for a long time. There's no real way of fixing that. They're talking about ways, but it's going to be a long time. It's been estimated that 8,000 picocuries per kilogram of cesium has been found in Northwest, which is over 10,000 times or higher than what they have recorded in the past. And I-31, iodine-131 is 100 times of normal up in that area. Dr. Sherman has done some studies up in that area, and she found that year over year there was 14,000 additional deaths up in the Northwest, and it came mostly from pneumonia and thyroid-related diseases, and nobody reported any of that. That just come from her study, but that wasn't reported out in the open. And she projects that they're over time, and this is mostly young children, and they were mostly susceptible in their lungs. And she projects, over time, 10, 50 years, there are going to be millions of deaths across the United States, and they're just so subtle in the form of cancer and other increased health diseases. You won't know this, you won't see it. There'll just be increased death rates. other nuclear plant failures that you're pretty much aware with, the Chernobyl catastrophe, and that's still putting out radiation across Europe over there. The 3 Mile Island and Fukushima, that's putting out right now the equivalent of 10 nuclear Hiroshima bombs per hour. And then they don't tell you about the leaking nuclear plants that we have here in the United States. Up in Washington, and the California San Onofre plant has had problems. I just heard this afternoon somebody was telling me that shortly after Fukushima, the San Onofre plant developed cracks in it, and there's a theory that scalar weapons were actually used to create the tsunami in Japan to cause that failure over there in Fukushima. And the cracks that we saw in San Onofre may have been a revenge attack from someplace else. So there's all these other theories going on out there, but it's some of it may be real. We have different risks that go on with these plants across the United States. I'll get to that. Other emergency shutdowns, mostly due to weather over time, that have occurred to plants across the United States. And then we have nuclear waste that we have to worry about. So what if we don't have a catastrophe? We still have to get rid of the nuclear waste. And it's always not in my backyard, you don't. And so and this is accumulating over time. I say, oh, we have all these solutions, and but it's still piling up. And what do we do with it? Poisoning the earth. Here's an example of a storage waste in Russia, a salt mine. They just drop it down in a salt mine. There's a lot of, some of the countries are actually dropping their nuclear waste in the ocean. They just go out and dump it in the ocean, and deep trenches supposedly, but still over time it's affecting the earth and the interior. And I look at the earth as a living system, and just like our own body. And so when you poison it, bad effects are going to happen over time. So the continued risk with nuclear power plants are going to be with the natural disasters, the earthquake, the tsunamis, the floods, and the loss of cooling water, and then they have to go to an emergency mode, and they can hope they control the reaction and not get a meltdown. My understanding in Fukushima, they are now melting through. That's the underground reports, and so it's getting into the groundwater over there in Japan. And then there's just the people problems. You've got all the manufacturing problems. You got the politics. You got the management processes that you have to go through, and people are just human, and they make mistakes, and we don't design infallible devices. I'm a scientist. I have a physics degree, and I'm an engineer, and I've always believed that you can engineer science and use science to solve any problem and engineer anything. And I recently did some studies in the fracking area, and while I still believe you can do fracking safely, when you get the human element involved, to save on money and take care of the politics, it's just a dangerous situation. It just doesn't work. And over time, these plants are going to age, and you're going to have to replace them. So we're talking about replacing. We're talking about increasing the number of plants. As far as I'm concerned, the risk of using nuclear power are just far too great to continue going in that direction. The risk of one catastrophic failure, to me, is not worth all the electrical power generated around the world. It is just not worth it. I'm reading a book called Infinite Energy Technologies, and it has a foreword by Paul Hawken, and he brings out the concept of spaceship Earth. And so if you built yourself a spaceship and you wanted to travel for 300 years, How would you build that spaceship? How would you feed yourself? How would you recycle all the waste that you created so that you're going to, and your next generations arrive there healthy? We need to think of our spaceship Earth in that manner. And nuclear power plants is not the way I would design our spaceship Earth. Radioactivity that we're putting out through Chernobyl and Fukushima is going to last hundreds and thousands of years. In the meantime, there are long-term solutions. There's breakthrough energy that we're going to talk about, and that we replace nuclear power with, and with the problems that we now have with radioactivity, there are some solutions using remediative processes, and we're going to talk about that. So the solution to cleaning up the nuclear poisoning of our planet is, and I think starting off with educating our citizens about the poisoning, the cover-up that's going on in our governments. We need to contact our legislatures, make sure we don't build any new ones. We need to start decommissioning the plants. We need to get rid of the aging leakers first. And then we need to talk about doing some research into neutralization of our radioactive fallouts wherever that may occur, and do some mitigation, and also spend some money on research in this area of mitigation and neutralization. And then we need to get beyond that and start looking at the promising new breakthrough energy technology and get them online as soon as possible, bring down the grid so we don't even have to have a grid. We'll talk about the new breakthrough energy technologies also. There are some already proven mitigation technologies based on both mainstream and some breakthrough technologies. And I've divided it between three areas. One is high temperature plasmas, low nuclear reactions, and electromagnetically generated scalar waves. All three of these areas have demonstrated that you can mitigate and neutralize radioactivity, which we are not looking at or doing at this point in time. Just to go through a few of these technologies, this is mainly from a report by Mike Paringa from PACE, Planetary Association for Clean Energy, some time back. Brown's gas has a unique property. It creates a plasma. In an environment, it will reduce radioactivity by 95%. I've read those reports before. Photodecactivation, where you use an electron beam directed onto a tungsten target, and then that re-radiates radioactive waste and reduces the radioactivity that way. There's a ZIP fission and fusion process where you submit the rad waste into a carbon arc underwater, and I have a friend who worked with that and actually saw that demonstrated. There's bionuclear remediation. It's amazing what our bodies, the biological processes can do to clean up our bodies. There's the Monte process, which is confined explosions. And then there's the Tom Bearden approach of using non-Hertzian waves, which is just basically scalar waves. Use them in an interferometric process to transmute the radiation and also reduce it. And there's also we've seen Ken Rolla here at the conference. He's building these scalar disks that are passive disks that put out scalar waves, and that would be expected to neutralize radioactivity in addition to dealing with chemtrails and other poisonous substances in the atmosphere. And the thing I like about Ken Rolla's technologies is that it's open source. Anybody can make these. You can put them out in your backyard, spread them around, surreptitiously undercover. there's all these different technologies are available. We can put more money into it, do more research. It'd be nice if the government did that and helped us, but we need to get together as citizens and start thinking of how we do that. There's some solutions already exist, and there's much more research to be done, but we can get started now. One of the things that I'm thinking we ought to do is citizens ought to get together in their local communities and just talk about this. And you could send somebody to your local university. University of Denver has a class for a radiology expert, and so you can get educated on measuring radioactivity and the health effects of radioactive materials, and learn how to measure the radioactivity fallout your cells. So that's something that citizens can do. So what do we do to replace nuclear power generations? Well, I think the transition is going on now. We're using renewable energy, sun, wind, and solar solutions, the geothermal. The other thing is we're also talking about clean fuels, attempting to go in that direction. I thought we'd have hydrogen by now, but we don't. Natural gas is pretty clean. I just found out that up in Weld County here, one of the largest counties in the world, the ERA, or the REA, Rural Electric Association there, we have a lot of oil drilling going on in this area. And so they have to create energy to power their drilling operations and pumping operations. And so what they do is they take the natural gas that they capture right at the well, and they put it through a generator there used to power their generators. I found out they're generating 3 megawatts of power off these co-generators right there in Weld County. And so there you go, without having to have all the grid. We have locally other clean fuel, clean coal. That's an oxymoron to some people, but we have a company down here in South Denver, Veritech Corporation, who is advertising clean coal. I visited them, and they actually have a process, a tabletop prototype process that uses some electronics and some electromagnetic waves to actually dissociate dirty coal, get the individual elements out, and he comes up with blocks of clean carbon. And then you burn that carbon in a plant, you get the CO2 out, and you use the same process to turn the carbon dioxide back into carbon and oxygen. So, I'm rooting for him. And then we've had, a lot of work being done on hydroxide technologies for the generation of hydrogen, and I'll talk about one of those in a minute. But yeah, the new energy paradigm really needs to be the breakthrough energy technology, and our conference is demonstrating that there's just a tremendous amount of people out there working on this, and practical devices come to the forefront. And so I'm just going to kind of skim through, give you an idea of the magnitude of the work that's really going on in breakthrough energies. Here's a number of different forms of energy and people working on breakthrough energy. So you go from thermal energy, radiant energy, elastic energy, luminous energy, all these different type of energies available to work on for free energy. What is free energy? That begs the question to most people who, free energy, you can't make something out of nothing. Well, it really isn't free, of course. You have to work to get it out. But what do we mean by free energy? Starting out, it describes it as the energy that is available from the universe for the taking at any time for any use. Peter Lindemann uses the definition, free energy is any energy that is provided by the natural world. And my own definition is free energy is that free energy contained within the ether that's between all of the space. That's what I call the basic source of free energy that's out there in the universe that we're not aware Solar, wind, gravity, these all too can be forms of free energy, if you will. There's a long history of free energy research. In looking back into it myself, Leonardo da Vinci is actually the beginner of it all with his illustrations. There's always he had his drawings where he had the water paddle, and you see the water coming off the paddle and come back up the top and going around. His perpetual motion machine, that was the first free energy device from my perspective. There's been dozens of inventors since then that have brought forth different ideas, working inventions since then, including Nikola Tesla. We'll talk about that. There's thousands of breakthrough energy scientists and engineers and even scientists in academia now getting on the bandwagon, working on these devices. The march toward new energy society has been thwarted, however, by, I think, academia and a not invented here syndrome. But we're seeing a crack we're seeing a crack there right now. So from my perspective, we're still in a flat Earth kind of science society, but we're starting to get the word out there. Inventors of the past, I just listed out a few of the more famous ones. John Worley Keeley, all of his science was based on harmonics, and he demonstrated that in his devices that it isn't just the machine, the harmonies of the machine, but it can interact with the operator also, and so intention becomes involved in a lot of these free energy devices. And I think that's where you're able to control more how it's used. Victor Schwabarger is famous for his studying water and the vortices and the natural healing processes that water goes through vortices and the action of the water going down the stream. And a lot of purification devices have come from his studies of water. Thomas Henry Murray is famous for his 50 kilowatt radiant energy device where he uses wires to accumulate radiant energy and then light up 50 kilowatts worth of, and it's based on his famous Morey valve, but he had a hard time convincing people that he wasn't using some kind of magic for that. Nathan Stubblefield built the first wireless telephone even before Tesla. A lot of earth batteries he's famous for, an area of interest that I have. Herman Plasson harvested energy from the atmosphere, actually used it in some airplanes in some cases. And Lester Hendershot, famous for his fuel-less motor, it's believed that they may have used his device on the what's his name? The guy that flew across the ocean the first time. Yeah. Charles Lindbergh. The first guy that he hugged when he got off his plane when he landed in Europe was Hendershot. So some people believe that he actually that plane was actually flown by his motor. John Searle, famous for his magnetic circulating magnetic motor. I finished a book last year by John Violette in anti-gravity propulsion, and he really goes into detail on the science of John Searle's motor. Very interesting. When he experimented that, he lost many of those into space, and now we've got other people experimenting with that motor, including Jason Verbelli and with a group down in San Diego. Bruce De Palma, motor generator. Peter Lindemann did an excellent talk on how a motor and a generator works, and got an old textbook and demonstrated that a motor and a generator should actually have a theoretical coefficient of performance of 2. And that's because when you pulse a coil, you get a back EMF out of that. And so when you learn to control what's going on in the motor, you get what you put into it plus what come out the back. And so that's the basic principle to a lot of those motor generator type of research. The Bedini motor, which I have built and experimented with, and I've had successful results with that. Edwin Gray, don't know, I'm not that familiar with the capacitor discharge engine, which somewhat makes sense. Joseph Papp and John Roeder of Intelligentry has been experimenting with that. I'm not sure he totally understands that, but it's they're using a gas plasma and trying to generate energy in a like a car engine. Well, of course, the hero and avant-garde of all the free energy movement of Nikola Tesla, whose name is being taken out of the textbooks, and so we're not able to appreciate what he really did. He has more than over 600 patents that are related to electromagnetics, electrical devices, and it goes on and on. Famous for his Tesla coil, which everybody is experimenting with, and he's more well known out in the world for his practical applications, the AC motors that drive all of our industry these days. And we wouldn't have the grid if it wasn't for Nikola Tesla, because he demonstrated that AC was the only way that you could propagate energy over long distances, whereas Edison with his DC could only propagate it over a few miles. Why hasn't free energy come to the forefront? It's suppression, basically. Renzi.com, and I think Rex researchers, other sources, have talked about different people who have been killed because of the work they've done in the free energy area. The one person that I sync with is probably Eugene Maloff, who was the editor of the Infinite Energy magazine, who just happened to be bludgeoned to death in a supposed raid on his house. And so the list goes on and on. So many of us are familiar with that. I haven't heard that many frequently. I think we're overwhelming them with the numbers at this point in time, hopefully. On the other hand, there's just hundreds and thousands of people who are working in their garage, professional scientists, engineers, just plain old people just fascinated with this science and are experimenting with it. You can go to Rex Research and get a whole list of these guys. I just got the list up through B here, so just give you an idea of the number of people that are being reported on that are actually working on different free energy technologies. Free energy contemporaries, there's a whole list there, starting with De Palman. I haven't listed them all. Just to give you an idea, T. Townsend Brown with his electrolytic motor and gravitics, which, by the way, when I read that book about gravity propulsion, in there he talks about T. Townsend Brown, and he claims, in talking to people who have been in the black programs, that technology is actually on the B-2 bomber. When they get it up to altitude, they convert over to the static discharge as a way of propelling that plane. Yule Brown is responsible for Brown's gas, and a lot of people are experimenting with Brown's gas, which is a form of water, or hydrogen and oxygen that comes from water, that is not an O2 and an H2, but it's a combination of the two together that doesn't burn until you put enough energy to it, and when it burns implosively and then expands with the heat, and has some very interesting characteristics, as many of you know. Andrea Rossi, he's got a low energy nuclear reaction generator over in Europe, and my understanding that has been validated. He's got a 1 megawatt machine that he's going to be bringing to the United States in the very near future, try out over here, demonstrate over here, and that one is over Unity. There's a whole wide range of technologies from which free energies can be obtained, and I've just listed out some of the very limited number of low energy or technologies you get free energy from, and I've bolded those that I think are kind of in the forefront of the free energy technology at this point in time. Hydrogen Brown's gas, where you get the hydrogen out and use it to burn in motors. Motor generators are very prevalent in the experimentation stage now, and I haven't personally witnessed any of those, but seen a lot on YouTube. Nuclear cold fusion. I actually got to see a talk by Pons and Fleischmann when they first introduced the cold fusion, and then they were driven out of the country. Japan really picked up on the research on that, and doing a lot of good work over there in Japan and nuclear cold fusion. There's a whole wide range of cold fusion work in that area because it's based in kind of on electrolysis, and now we've gotten into, you heard the talk by Moray King talking about cavitation, and I actually did some experimentation with electrolysis using stainless steel and some pure water, and actually got some transmutation in that cell based on reports by metallurgists that I worked with. So this is real stuff, and just needs money, needs research to get it into practical devices. There's a lot of solid state technologies are demonstrating violations of the second law of thermodynamics. Kinetic energy devices, plasma devices, crystal energy, electromagnetics, and I mentioned electrolysis, vortex technologies. Vortex seems to be a key in a lot of these different free energy technology when you start looking into the ether-based technologies. I like the theories of Nassim Haramein and his black hole theories and the toroidal theories, and going from the atom up to the universe. Everything should work the same. That is my theory. I'll give a couple of examples of, as part of New Energy System Trust, we are sponsoring a couple of individuals and their research at this point in time because we feel they're really valid technologies that need funding. One is Edward Mitchell with True Green Solutions is working on a replication of Stanley Meyer's technology. And Stanley Meyer's technology is not the usual HHO, because what he's doing is he's using voltage and frequency to really just dissociate the water molecule into hydrogen and oxygen, and then you can burn it from that point of time. And he has demonstrated in his car, supposedly, a on-demand ability to provide enough hydrogen to run his car, and then he didn't have enough safety devices in the first time, so he had an accident. Now he's on his second series of prototypes, and he had this one working at the conference, but he had the wrong resistor in there or something, and he lost it the first time. So he's got a little more work to do. And it can be used on other gases, other fuels, so not just water. And so he talks about actually using as a gas exciter in the intake manifold to take out the pollutants and dissociate the particles coming in. And you can do that on the output also. So there's a picture of his devices that he has here at the conference, at least the one on the right. The other one's his old old version of that water fuel capacitor, as he calls it. And then I am representing a booth by Electron Power Systems, Clean Fusion Energy. Clint Seward, he's what I call a professional's professional. He was in one of the major corporations back east, and he was in the military. He was a manager. When he retired, he decided, I want to do something unique. And he settled in on ball lightning. He says, nobody is studying ball lightning. So he decided to study ball lightning and build his own little laboratory and start experimenting with it. Well, he finally got to the point where in researching, and he realized that lightning is created from the ionosphere down to the Earth, and it's a little less than atmospheric pressure up there at the ionosphere. So in his bell jar, he reduced from atmosphere down to a lower pressure, and he started getting some results. One day his wife was in there, and he says, I'm just not getting anything out of this. And she says, well, what are these little tiny things floating around at the bottom? And so they amplified these little floaters that were down at the bottom when he turned off the electricity, and sure enough, there were little toroids. So he finally figured out how to create a toroid, and there's an example of a toroid. That's actually a 15 centimeter. His first ones were very small, but he got these 15 centimeter toroids, which are he can control them, move them back and forth. He can keep them going indefinitely. So once he creates a toroid, it continues to exist. So he's at this point where he wants to create two toroids in the same chamber and then collide them. So whatever gases that you're using in there, whatever ions are in that toroid, you can just collide them with two toroids, and then you have a fusion process. So his theory is that he can create a home generator with a fusion process using a hydrogen boron process, which supposedly lacks radiation and neutrons that come off your typical fusion process. So this really looks very promising at this point in time. And that's a picture of his laboratory. That's his bell jar in the background back there, and it doesn't show his power rack, but then there's his computer control system there. So a real laboratory and a real live scientist. By the way, he has a model for those toroids, and he's been working with an MIT doctor who believes in his work and has been working on that mathematical one. So far, all of his results have followed that mathematical model. So what are the obstacles of getting free energy out there? Well, there's a lot of vested interest in not wanting free energy to get out there, and a lot of that has to do with money and power. The government has its own black programs. In the book by Paul LaViolette, Anti-Gravity Propulsion, he says that they have that science already, they have it written down. They have the science of free energy technologies all written down. They have their own flying saucer fleet. So there's all that money in those black programs are going into that, and they're just keeping it from us. Oil industry, of course, is invested in their the money they make off of all of the oil that they extract from the earth, which I don't think is good over the long term, besides the pollutant that you create in burning the stuff. And then the automobile industries, which use the oil, are tied together with the oil industry, so they don't want to change the efficiency of your engines or replace the type of engines you use. Even if you go to electric cars, you got to burn fuel to generate the electricity someplace. So it's just all tied together. And then there's what I call the mainstream good old boys science club that just sticks to their traditional science and doesn't want to venture out. And it comes in the universities. It comes in the journals. The people that are in control of all the journals where you write your articles. And some people may actually get some advanced research and get into those journals, but then when they figure out that they're violating the second law of thermodynamics, then it's cut off. Or if it's going to create a device that is going to substitute for oil, it gets shut off. It just happens over and over. Well, what would be the advantage of getting to free energy besides replacing nuclear power plants? Tremendous amount of freedom in this country, and freeing up of our wealth for the individual. Travel. If you could use anti-gravity devices, you have fuelless and free energy cars. You have fuelless cars, electric cars. Use water for your power. Have anti-gravity, and if you get to anti-gravity devices, we can start moving out of the big cities and move into the country, and then you use anti-gravity propulsion. You create small communities, and you can commute with these anti-gravity cars from one place to another, so simply without roads, and just so much freedom. And you get out there and you have your own free energy power devices out there. You don't have to rely on a grid. You spread our civilization out, have these small communities, and you have maybe communities where you have it's industrialized, and so that's where you go to work. And so it's just a whole, and with the whole change in the economy, no more taxes on the grid, and much cheaper fuel costs because you're generating it on your own. So how do we go about getting this free energy society going? Well, I think we have to start, of course, organizing and educating the public. We need to go into our legislatures and educating our legislative people who are local elected officials, not the professional political people that are back there. And we have to continue these free energy conferences, expand on them, and maybe specialize in the type of conferences you have. The technical guys really love to get together and talk about the technologies. We were talking to Catherine Fitz the other day, and she said it's not about the technology. People don't care about the technology. The normal person on the street. You don't care about the technology. Just solve a problem. But if you can solve his problem with free energy technology, then he's going to be very happy. He didn't care whether he has to pay for it or not pay for it. But it solved his problem. So that's the way we have to go. We have to establish new funding sources. Anybody for an ice cream? Can you wait just a minute? And then we have to, I'm involved in an energy incubator. Major universities have incubators where they bring technology from the university out into the market, and they create funding for that and help them along the way. That's what we need to do with free energy, develop free energy incubators and link up with some funding. So let's get with it. Let's organize. Let's embrace free energy technologies and bring it into the world. The new paradigm has got to be free energy, and breakthrough energies sans the grid. And we can transition to this new paradigm with renewable energies at this point in time, and even combine free energy technologies, energy amplification technologies with new energy technologies to do this. Science and engineering must get beyond the square root of -1. The square root of -1 is an imaginary 1i in mathematics, and there is a mathematics beyond that that most engineers have thrown it away because in our 3D system it isn't needed. But now when we get to learn about free energy, we're starting to find that in the ether, in order to understand that, we got to get into the that mathematics is beyond the square root of -1. We have to embrace the new quantum physics, the multiple dimensions of space-time physics, and create a whole new ether science to understand this free energy and bring it into the world. Thank you. And I will answer a couple of quick questions right now. If, yes.
You mentioned a writer by the name of
We need to get you a microphone, I think.
From the Tesla Science Foundation, and just a question. You mentioned a writer by the name of, I thought I heard Violet or something like
Paul
that.
LaViolette. Paul LaViolette. You can find that book actually in the physics section of Barnes and Noble, believe it or not. Anti-gravity propulsion.
I have an email list, and if you've written anything, I'd like to send it out on the email list. It's got about 80 people on it devoted to exotic clean energy. Have you heard any books or essays that people can read? It's a little hard to absorb all that, as you go from one picture.
The one that I'm reading now is excellent for a basis of it, and that infinite energy technologies. And Ebersole is the editor on that book. Would be a good book to take a look at. Anybody else? I must have did a great talk. Thank you. Thank you, Jason.
All right, we're going to take just a few moments for